Now, in this lecture, we'll find out the radius of the circle. In the drawing, we have a big semicircle. Inside this big semicircle, we have two smaller semicircles and one circle. It's given us the equation that this line segment equals to 140 units, and this line segment equals to 70 units in its length. And our mission is to find out the radius of this circle. So first of all, we will define the relevant points for our question. This point will be defined as A. The center of this semicircle here will be defined as B. The touching point between this semicircle and the small semicircle will be defined as C. The center of the biggest semicircle is here. It will be defined as O. The center of the smallest semicircle here will be defined as D. The touching point of the biggest semicircle with the smallest semicircle here will be defined as E. The center of this small circle will be defined as F. The touching point between this circle and the smallest semicircle will be defined as G. The touching point of this circle with this semicircle will be defined as H. And finally, the touching point of this circle with the biggest semicircle here will be defined as I. So, and we also define the radius of the biggest semicircle as capital R, and we define the radius of this circle as small r. So I write it down. Capital R is the radius of the biggest semicircle and small r is the radius of the circle. That is the radius that we are looking for. Radius of the circle. It is given as the question that this line segment AE equals to 140 plus 70 units. So I write it down. According to what is given as the question, AE, line segment AE equals to 140 plus 70 units. That is 140 plus 70 is 210 units. AE, line segment AE equals to 210 units in its length. But what is actually the definition of line segment AE? AE is the diameter of the biggest semicircle. So I write it down. AE is the diameter of the biggest semicircle. And we just right now found out that A equals to 210 units in its length. And because of the fact that the radius of the biggest semicircle equals to capital R, the diameter must be equal twice of the radius. That is to say, the diameter must be equal to 2 times capital R. And from this long equation, 2R equals to the diameter equals to A equals to 210, we'll derive the 2R, 2 times capital R, equals to 210 units. Here we divide this equation by 2 and we get that capital R, the radius of the biggest semicircle, equals to 210 over 2 is 105 units. So we found out that the radius of the biggest semicircle equals to 105 units in its length. Point O is the center of the biggest semicircle. Point A is the point on the biggest semicircle itself. So OA is the radius of the biggest semicircle, that is equal to 105 units. Likewise, point O is the center of the biggest semicircle, point A is a point of the biggest semicircle itself, therefore OE is also the radius of the biggest semicircle, that is equal to 105 units. Okay? And it is given us the question that line segment AC equals to 140 units. What is AC? AC is the diameter of this semicircle, and if the diameter of this semicircle equals to 140 units, it means that the radius of this semicircle equals to half of it. That is to say, the radius AB equals to 140 over 2, that is 70 units. AB equals to 70 units. And the radius BC of this semicircle also equals to 70 units. Likewise, it is given us the question that line segment CE equals to 70 units in its length. But what is line segment CE? CE is the diameter of this smallest semicircle. And if the diameter of this smallest semicircle equals to 70 units, it means that the radius must be equal to half of it. So the radius of this semicircle must be equal to 70 over 2, that is 35 units. If CD, that is the radius of the smallest semicircle, equals to 35 units in its length. And DE also equals to 35 units in its length. Okay. What is the length of line segment BO? For Doing, it is very easy to see that VO equals to OA minus BA. Again, OA minus BA equals to BO. OA minus BA. It again, BO equals to OA minus BA. So BO equals to OA. OA is the radius of the biggest semicircle, that is equal to 105 units. So we substitute OA by 105 minus BA. BA equals to 70 units. It is the radius of this semicircle. So we substitute BA by 70. In conclusion, we found out that BO equals to 105 minus 70, that is 35 units. BO less 7 BO equals to 35 units in its length. Okay. And what is the length of line segment OC? From the drawing, it is very easy to see that OC equals to OE minus CE. Again, OE minus CE equals to OC. OE minus CE. Repeat again, that line segment OC equals to OE minus CE. So OC equals to OE is the radius of the biggest semicircle that is equal to 105 units. So we substitute OE by 105 units minus CE. CE equals to 35 plus 35, that is 70 units. So we substitute CE by 35. Again, CE equals to 35 plus 35, that is 70 units. Therefore, we substitute CE by 70. In conclusion, we found out that line segment OC equals to 105 minus 70. 105 minus 70 is 35 units. So OC equals to 35 units in its length. OC equals to 35 units in its length. In the next step, we'll present to you two new rules and we'll implement the two new rules in our drawing. The first rule is rule number 10. According to rule number 10, if two circles are touching each other internally in this drawing, the small circle is located inside the big circle and it touches the big circle at this point, point N. Point N is the point of tendency or the touching point between the two circles. Okay? So, the reason that this type of tangency or this type of touching point is defined as internal lunge is because of the fact that the small circle is located inside the big circle. Therefore, we said that those two circles are touching each other internally at point N. Okay, so we have here the two circles that are touching each other internally at point N. Then the straight line that connects their centers together. The straight line of the biggest, the center of the biggest circle is at point O. The center of the small circle is at this point, point M. And the straight line that connects their centers together is OM. This straight line OM, according to rule number 10, this rule must pass through their touching point, that is to say, through point N. Or in other words, OMN is one straight line. So whenever we have two circles that are touching each other internally, then the straight line that connects their centers together, in this case is OM, must pass through their touching points. In this case it is point N. So OMN is one straight line. Okay, and what is the distance between their centers? The distance between their centers is OM. And what is the value of OM? From the drawing, it is very easy to see that OM equals to NO minus NN. Again, NO minus NM equals to OM. NO equals to capital R, it is the radius of the big circle. NM equals to small r, it is the radius of the small circle. So in conclusion, we found out that the distance between their centers OM or MO equals to capital R minus small r. So whenever two circles are touching each other internally, then the distance between their centers will be equal to the difference between their radii. In this case, it's capital R and small r. Okay. And here also rule number 11. According to rule number 11, if two circles are touching each other externally, in this case, in the drawing, we have two circles that none of them is inside the other. Therefore, this type of tangency is defined as external touch. They are touching each other externally at point N, because none of those two circles are located inside the other. So if we have an external touch between the two circles, like in this drawing, then the straight line that connects their centers together, the center of this circle is at this point, point O. The center of the small circle is at this point, point M. And the straight line that connects their centers together is OM. Must pass through their touching point, that is actually point N. Or O and M is one straight line. Okay, so whenever you have two circles that are touching each other externally, then the straight line that connects their centers together must pass through their touching point. In this case, the straight line OM must pass through point N, that is to say O and M is one straight line. And what is the distance between their centers? The distance between their centers is of course OM. And here you can see that OM equals to ON plus NN. Why? Because O and M is one straight line, therefore OM equals to ON plus NM. ON equals to capital R and M equals to small r, and therefore OM in total equals to capital R plus small r. So in conclusion, we can say that whenever we have an external notch between two circles, then the distance between their centers will be equal to the addition of their radii with each other. In this case, it's capital R plus small r. Okay? D equals to capital R plus small r. We can actually implement the two new rules in our drawing. So first of all, if we join point B, that is the center of this semicircle, with the center of this circle that is here at point F, by a straight line, then because of the fact that this circle have an external notch with this semicircle, that is to say they are touching each other externally at this point H. Therefore, the straight line that connects their centers together is BF. The straight line BF must pass through their touching point, that is actually point F. Or BHF is one straight line. BHF is one straight line. And the distance between their centers is BF. B is the center of this circle, F is the center of, B is the center of this semicircle, F is the center of this semicircle, and the distance between the centers is BF. And whenever you have an external notch between two circles, according to rule number 11, the distance between the centers will be equal to the addition of the two radii with each other. The radius of this circle is small r, so FL equals to small r. The radius of this circle BH equals to 70 units, and therefore line segment FB, that is the distance between the centers of the circle and the semicircle, it is equal to 70 plus r units. So I write it down. Line segment BF equals to 70 plus r plus small r units. Repeat again, BF equals to 70 plus r units. In the next step, we join points D and F together by a straight line. D is the center of the smallest semicircle, F is the center of the circle. And the straight line that connects their centers together is DF. According to rule number 11, because of the fact that those two circles and the semicircle have an external line between them at this point, point G, then the straight line that connects their centers together, that is actually DF, must pass from point G. That is to say, DGF is one straight line. DGF is one straight line. And what is the distance between their centers? The distance is DF. And that distance equals to the addition of the two on the eye with each other. The radius of this circle equals to small r. The radius of this semicircle, the smallest semicircle, equals to 35. Therefore, in total, FD equals to FG plus GD, that is to say it is R plus 35. So I write it down, FD equals to R plus 35 units. What is the distance between points B and D? B is the center of this semicircle. D is the center of the smallest semicircle. Those two semicircles have an external arch between them at point C. That is to say, they are touching each other externally at point C. And whenever we have an external arch between two circles or semicircles, then the straight line that connects their centers together, that is to say BD, must pass through their touching point, that is actually point C. Or BCD is one straight line. BCD, and because of the fact that BCD is one straight line, it means that BD will be equal to BC plus CD. BD equals to BC plus CD. So BD equals to BC is 35 plus 35, so you can see from the drawing that is 70 plus CD. From the drawing it is very easy to see that CD equals to 35 units. So in conclusion, I found out that BD equals to 70 plus 35, that is 105 units. And the distance between two circles that have an external arch between them is the addition of the two radii with each other. The radius of this semicircle equals to 70 units. The radius of this smallest semicircle equals to 35 units. And the addition between the two radii will give us 70 plus 35, it is 105 units. So it is the second way to arrive to the same result, that BD equals to 105 units. In the next step, we will join the points of the biggest semicircle that is located here at point O with the center of this circle that is located here at point F. The biggest semicircle and this circle have an internal notch between them at this point I. Why? Because of the fact that the small circle is located inside the biggest semicircle. They have an internal notch between them at point I. That is to say they are touching each other internally at point I. And whenever you have an internal notch between two circles or semicircles, then the straight line that connects their centers together, that is to say OF, the straight line OF must pass through point I. Or in other words, OFI is one straight line. OFI is one straight line. And F is the center of this circle, I is the point of the circle itself, therefore Fi is the radius of this circle that is equal to R according to our definition. And what is the distance between their centers? The distance is OF. And according to rule number 10, the distance between the centers of two circles that have an internal notch between them will be equal to the difference between radii. The radius of the biggest semicircle equals to capital R. The radius of the small circle equals to small r. That is to say, OF, that is the distance between the centers, is capital R minus small r. But we have already found out that, that the radius of the biggest circle equals to 105 units. That is to say, capital R equals to 105 units, so we substitute capital R by 105. So it is 105 minus R, or F equals to 105 minus R units. Or F equals to 105 minus R units. That is the distance between the centers of the biggest semicircle and this circle. Okay. In the next step, I will present to you a new rule, and we will implement the new rule in triangle FBD. In the green triangle FBD. The new rule is true in any triangle, therefore we can implement it in the green triangle. So the new rule is Stewart's rule, Stewart's theorem. Because of the fact that Stewart's theorem is true in any triangle, so the triangle that I will draw here could be any triangle. This triangle ABC, could be any triangle. This is triangle ABC. Side AB equals to A units in its length. Side AC equals to B units in its length. And finally, side BC, this side equals to C units in its length. In addition, we have here line segment AO. This line segment equals to D units in its length. And we also know that line segment BO equals to M units in its length, and line segment OC equals to N units in its length. Then, according to Stewart's theorem, the following equation is true. A squared times N plus b squared times m equals to c, and we'll open the brackets here. Inside the brackets we have d squared plus m times n. Repeat on Stewart's theorem again. In any triangle, the following equation is true. A squared times n plus b squared times m equals to c, and inside the brackets we have d squared plus m times n. We can implement the Stewart's theorem in our green triangle FBD. So I copy triangle FBD in a new page and we implement on it Stewart's theorem. We have already found out all the sides of the green triangle, so I'll not repeat on it. FBD FB equals to 70 plus R, FD equals to 35 plus R, and finally BD equals to 105 units. And this is triangle FBD that I covered from the original drawing. We also know that line segment FO this line segment FO equals to 105 minus small r units. What is the length of line segment VO? From the drawing, it is very easy to see that BO equals to 35 units. So right now, BO equals to 35 units. And what is the length of line segment OD? From the drawing, it is very easy to see that OD equals to 35 plus 35. Or OD equals to OC plus CD. OC is 35 and CD is 35. Therefore, OD equals to 70 units. OD equals to 70 units. So we'll implement on this triangle FBD Stewart's theorem. According to Stewart's theorem, FB squared times OD plus FD squared times BO equals to BD, and inside the brackets we have FO squared plus BO times OD. So this equation is the implementation of Stewart's theorem in our triangle FBD. I repeat again, FB squared times OD plus FO squared times BO equals to BD, and inside the brackets we have FO square plus BO times OD. Okay. So FB equals to 70 plus R, therefore FB square is 70 plus R square times OD. OD 70, so we substitute OD by 70 plus FD square. FD is 35 plus R, therefore FD square is 35 plus R square times BO. BO is 35, so we substitute BO by 35. And it is equal, in the other side of the equation we have BD. BD is 105, so we substitute BD by 105. And inside the brackets we have FO square. FO equals to 105 minus R. Therefore FO square equals to 105 minus R square plus BO is 35 times OD, that is 70. So it is 35 times 70, all in brackets. Here we substitute the number 35 or any multiplication of 35 by a natural number by x. 35 equals to x according to our definition. So here we have 70. 70 is 2 times 35, therefore it is 2x plus R square times 70 is 2x times 2x plus 35 is x, so it is x plus R square times 35 is x, so we substitute 35 by x. And it is equal to 105. 105 is 3 times 35, that is to say it is 3x. Inside the brackets we have 105, that is 3x, minus R squared, plus 35 is x, and 70 is 2 times 35, that is 2x. So here we have this expression in total equals to x times 2x. All under the brackets. So here we'll divide this equation by x. So here x will get cancelled, here also x will get cancelled, and here also x will get cancelled. So what is left from this equation after we cancel x? Here we have 2 times 2x plus R square plus x plus R square equals to 3, and inside the brackets we have 3x minus R square plus x times 2x is 2x squared, all under the brackets. So here we will open the brackets and we will get that we have 2 times 2x plus R is 2x squared, that is 4x squared, plus R squared, plus 2 times 2x times R is 4xR, plus x plus R squared equals to x squared plus R squared plus 2xR, and in the other side of the equation we have 3. We will open the brackets of 3x minus R squared according to the algebraic identity that a minus b squared equals to a squared plus b squared minus 2 times ab. So 3x minus R squared will be equal to 3x squared, that is 9x squared, plus R squared minus 2 times 3x times r is minus 6xr plus 2x squared. So in conclusion, we found out that we have here this equation. So we will open the brackets in this side of the equation and we get that two times 4x squared is 8x squared plus 2 times r squared is 2r squared plus 2 times 4xr is 8xr plus we have here x squared plus r squared plus 2xr. That is equal to, here inside the brackets we have 9x squared plus 2x squared is 11x squared plus r squared minus 6xr. So in this side of the equation we have 9x squared plus x squared, 8x squared, here it is 8x squared plus x squared is 9x squared plus 2r squared plus r squared is 3r squared plus 8xr. And here we have 8xr plus 2xr is 10xr. It's 10xr. And is equal to, we'll open the brackets here, 3 times 11x squared is 33x squared. 3 times r squared is 3r squared plus 3 times minus 6xr is minus 18xr. Here we have 3r squared on both sides of the equation, so 3r squared will get cancelled. What is left from this equation after we cancelled 3r squared? We have 9x squared plus 10xr equals to 33x squared minus 18xr. Here we subtract 9x squared from this equation and we get that 9x squared minus 9x squared is 0, so what is left here is only 10, and this side of the equation is only 10xr, that is equal to 33x squared minus 9x squared is 24x squared. We have here also minus 18xr. So here we will add to this equation 18xr and we'll get that 10xr plus 18xr is 28xr. That is equal to 24x squared. 18xr minus 18xr is 0. So in conclusion, we found out that 28xr equals to 24x squared. Here we will divide this equation by x and we get that 28xr over x is 28r. That is equal to 24x squared over x is 24x. Here we will substitute x by 35 and we get that 28r equals to 24 times 35. We substitute x by 35. Here we divide this equation by 7. So we found out that 28r equals to 24 times 35. We will divide this equation by 7 and we get that 28 over 7 is 4. In total, in this side of the equation we have 4r. That is equal to 24 times 35 over 7 is 5. So in conclusion, we found out that 4r equals to 24 times 5. Here we will divide this equation by 4. And we get that 4r over 4 is r. and 24 over 4 is 6. So in total, in this of the equation, we have 6 times 5. We found out that r equals to 6 times 5. 6 times 5 is 30. So r equals to 30 units. That is the answer to our question. So here, the radius of this circle, small r, is equal to 30 units. In the next step, we will summarize the lecture. Okay. In the drawing, we have a big semicircle. Inside this big semicircle, we have 2 smaller semicircles and 1 circle. It is given us the equation that AO equals. It is given us the equation that line segment AC equals to 140 units and line segment CE equals to 70 units. Our mission is to find out the radius of this circle. We define the radius of the biggest semicircle as capital R. The radius of this small circle is small r. Capital R is the radius of the biggest semicircle, small r is the radius of the circle. It is given us the equation that AE equals to 140 plus 70. AE equals to 140 plus 70, that is 210. So A equals to 210 units. And because of the fact that the radius of this biggest semicircle equals to capital R, and we know that line segment AE is the diameter of the biggest semicircle, it means that the diameter AE must be equal to 2 times capital R. Okay? The diameter AE must be equal to 2 times capital R, and we already found out that AE equals to 210 units. So from this long equation, we will derive that 2R equals to 210. We divided this equation by 2 and found out that R equals to 210 over 2, that is 105 units. So here the radius OE equals to 105, the radius OA of the biggest semicircle equals to 105 units. Then we have here AC equals to 140 units. But what is AC? AC is the diameter of this semicircle. And because of the fact that the diameter of this semicircle equals to 140 units, it means that the radius must be equal to half of it. The radius must be equal to 140 over 2, that is 70. The radius AB equals to 70, and the radius BC equals to also 70 units. Likewise, we have the diameter of this smallest semicircle equals to 70 units. Therefore, the radius CD equals to 35 and the radius DC equals to 35 units. In the next step, we found out the length of this line segment OB. From the drawing, it is very easy to see that OB equals to OA minus BA. I'll repeat again. OB or BO, it is the same, equals to OA minus BA. OA is 105, BA is 70, so BO equals to 105 minus 70, that is 35 units. BO equals to 35 units. In the next step, we found out the length of this line segment OC. From the drawing, it is very easy to see that OC equals to OE minus CE. Repeat again. OC equals to OE minus CE. OE is 105. It is the radius of the biggest semicircle. CE equals to 70 units. This is the diameter of the smallest semicircle. So in conclusion, we found out that OC equals to 105 minus 70, that is 35 units. Here OC, this line segment equals to 35 units in itself. In the next step, I presented to you 2 new rules, and we implemented the 2 new rules in our drawing. According to rule number 10, if two circles are touching each other internally, here the touching point is this point N, then the straight line that connects their centers together, the center of the big circle is at point O, the center of the small circle is point M, and the straight line that connects their centers together is the straight line OM. This straight line OM must pass through point N, that is their touching point. Or in other words, OMN is one straight line. And what is the distance between their centers? The distance is OM. OM equals to NO, that is capital R, minus NM, that is small r. So the distance OM equals to capital R minus small r, that is the difference between their radii. Okay, then we have also rule number 11. According to rule number 11, if two circles are touching each other externally, those two circles are touching each other externally at point N, then the straight line that connects their centers together, point O is the center of this big circle, point M is the center of the small circle, this small circle. Therefore, OM is the straight line that connects their centers together. This straight line OM must pass through their touching point, that is point N. That is to say, ONM is one straight line. And because of the fact that ONM is one straight line, it means that the distance between their centers OM must be equal to ON plus NM. ON is capital R, NM is small r. So OM equals to capital R plus small r. So whenever we have an external notch between two circles or semicircles, the distance between the centers of the circles or semicircles will be equal to the addition of their radii with each other. In this case, OM equals to capital R plus small r. We can implement rule number, the two new rules in our drawing. Why? Because in our drawing we have this B is the center of this semicircle, F is the center of this circle, and FB is the straight line that connects their centers together. And because of the fact that the circle have an external notch between this semicircle at point H, then the straight line FB that connects their centers together must pass through point H. Or in other words, FHB is one straight line. And therefore, because of the fact that FHB is one straight line, it means that the distance between their centers, whenever we have an external notch between them, will be equal to the addition of their radii with each other. The radius of this circle is small r. The radius of this semicircle equals to 70. Therefore, in total, FB equals to 70 plus r units. Here, FB or BF equals to 70 plus r units. We connected points D and F together by a straight line. The smallest semicircle have an external notch between this circle at point G. And therefore, the straight line FD that connects their centers together must pass from their touching point, that is to say from point G. That is to say FGD is one straight line. FGD is one straight line, and the distance between their centers, FD, equals to the addition of their radii with each other. The radius of this circle equals to small r. The radius of the smallest semicircle equals to 35. Therefore, the distance FD between the centers will be equal to 35 plus r units. Here it is 35. FD equals to 35 plus r units. And again, we found out the length of line segment BD. B is the center of this semicircle. D is the center of the smallest semicircle. And they have an external notch between them at this point C. Therefore, the straight line BD that connects their centers together must pass for their touching point, that is point C. Or BCD is one straight line. BCD is one straight line, and the distance BD between their centers is the addition of the radii with each other. The radius of this semicircle is 70 units. The radius of the smallest semicircle is 35 units. 70 plus 35 is 105. In conclusion, we found out that BD equals to 105 units. And then we have joined the center of the biggest semicircle with the center of this circle. So we joined points F and O together by a straight line. And because of the fact that the biggest semicircle have an internal notch with this circle at point I. That is to say they are touching each other internally at point I. And whenever you have an internal notch between two circles or semicircles, then the straight line that connects their centers together, OF, must pass through their touching point that is actually point I. Or OFI is one straight line. OFI is one straight line. And because of the fact that OFI is one straight line, IF is the radius of the smallest of this circle that is equals to small r. And what is the distance OF between their centers? The distance between their centers FO equals to the difference between their radii. The radius of the biggest semicircle is capital R. The radius of the small circle is R. And the difference between their radii is capital R minus R. Again, here, we found out that the distance between their centers OF is capital R minus small r. But because of the fact that capital R equals to 105 units, we substitute capital R by 105 and found out that OF equals to 105 minus R units. Here OF equals to this line segment FO equals to 105 minus R units. Then I presented to you a new rule and we implemented the new rule in our drawing. We implemented the new rule in the green triangle FBD. According to the new rule that is Stewart's theorem, the new rule is true in any triangle. We have this triangle ABC. The length of AB is A units, side AC equals to B units in its length, side BC equals to C units in its length. In addition, we know that line segment AO equals to D units, line segment BO equals to M units in its length, and line segment AC equals to N units in its length. Then according to Stewart's theorem, A squared times N plus B squared times M equals to BC. BC is C, so it is C. And then we open the brackets, and inside the brackets we have D squared plus M times N. Okay, C, inside the brackets we have D squared plus M times N, or A squared times N plus B squared times M equals to C, D squared plus M times N. This equation is true in any triangle, right? And because of the fact that triangle ABC could be any triangle, it means that the equation is true in any triangle. Okay, so we implemented Stewart's theorem in the green triangle FBD. So I copied triangle FBD in this new page. We already found out that FB equals to 70 plus R, FD equals to 35 plus R, BD equals to 105 units, FO equals to 105 minus R units. What is the length of BO? BO equals to 35 units, and OD equals to 35 plus 35, that is 70. Repeat again, BO equals to 35 and OD equals to 70 units. Implemented here, Stewart's theorem. According to Stewart's theorem, we get that FB squared times OD plus FD squared times BO equals to BD. Then we open the brackets. Inside the brackets we have FO squared plus BO times OD. I'll repeat again, FB squared times OD plus FD squared times BO equals to BD. And inside the brackets we have FO squared plus BO times OD. FB equals to 70 plus R, therefore FB squared is 70 plus R squared times OD. OD is 70, so substitute OD by 70 plus FD squared. FD is 35 plus R, therefore FD squared is 35 plus R squared times BO. BO is 35, so we substitute BO by 35. And it is equal to BD. BD is 105. And inside the brackets we have FO square. FO is 105 minus R, therefore FO square is 105 minus R square, plus BD is 35 and OD is 70. So in total, O times OD equals to 35 times 70. Then we substitute X, we substituted 35, or any multiplication of 35 by a natural number by X. According to our definition, 35 equals to X. And here we have 70 is 2 times 35, that is to say it is 2x. So 70 plus r square is 2x plus r square. 2x plus r square here. The square. 2x plus r square. The square is outside the brackets. Times 70. 70 is 2x. Substitute 70 by 2x plus 35 plus r square. 35 is x, so it is x plus r square times 35 is x. So we substitute 35 by x. So in this side of the equation we have 2x plus r square times 2x plus x plus r square times x. And it is equal, on the other side of the equation we have 105, that is 3 times 35, that is 3x. Inside the brackets we have 105, that is 3x plus minus r. This is 3x minus r square plus 35 is x and 70 is 2x. So in total 35 times 70 is x times 2x. Okay, then we divided this equation by x, and we found out that 2 times 2x plus r square plus x plus r square equals to 3, and inside the brackets we have 3x minus r square plus 2x square. Here we open the brackets, and we found out that 2 times 2x plus r square equals to 2x squared, that is 4x squared, plus r squared plus 2 times 2x, that is 4xr. So in conclusion, found out that 2 times 4x squared plus r squared plus 4xr equals to, here we have x plus r squared is x squared plus r squared plus xr. X squared plus r squared plus 2xr. It is 2xr. And it is equal, in the other side of the equation we have 3, inside the brackets we have 3x minus r squared. According to the algebraic identity, 3x minus r squared, according to the algebraic identity that a minus b squared equals to a squared plus b squared minus 2 times ab, we get that 3x minus r squared equals to 3x squared, that is 9x squared, plus r squared minus 2 times 3xr is minus 6xr. And we have also here plus 2x squared. So here in this side of the equation we have 3, inside the brackets we have 9x squared plus r squared minus 6xr plus 2x squared. Here we open the brackets. 2 times 4x squared is 8x squared, 2 times r squared is 2r squared, and 2 times 4xr is 8xr, plus x squared plus r squared plus 2xr. And it is equal to, here inside the brackets we have 9x squared plus 2x squared is 11x squared, and we also have here plus r squared minus 6xr. Here we have 8x squared plus x squared is 9x squared, 2r squared plus r squared is 3r squared, and 8xr plus 2xr is 10xr. So in this side of the equation in total we have 9x squared plus 3r squared plus 10xr, and it is equal to, we open the brackets here, 3 times 11x squared is 33x squared, 3 times r squared is 3r squared, 3 times minus 6xr is minus 18xr. So in this side of the equation, in total we have 33x squared plus 3r squared minus 18xr. Here we have 3r squared on both sides of the equation, so 3r squared will get cancelled. Then we subtracted 9x squared from this equation. 9x squared minus 9x squared is 0, so in this side of the equation we left only with 10xr. In the other side of the equation we have 33x squared minus 9x squared is 24x squared. And we have also here minus 18xr. So in conclusion, we found out that 8xr equals to 24x squared minus 18xr. Here we added 18xr to this equation. 10xr plus 18xr is 28xr. It is equal to 24x squared. 18xr minus 18xr is 0. So in this side of the equation we left only with 24x squared. In conclusion, we found out that 28xr equals to 24x squared. Here we divided this equation by x, and we got that 28xr over x equals to 28r, and 24x squared over x equals to 24x. In total, we found out in conclusion that 28r equals to 24x. Here we substitute x by 35, because according to our definition, x equals to 35, and we found out that 28r equals to 24 times x is 35. So 28r equals to 24 times 35. Here we divided this equation by 7. 28 over 7 is 4. In total, in this expression, in this side of the equation, we have 28 over 7 is 4. So in total, in this side of the equation, we have 4r. And in the other side of the equation, we have 24 times 35 over 7 is 5. So in total, in this side of the equation, we have 24 times 5, or 4r equals to 24 times 5. Here we divided this equation by 4, and we found out that 4r over 4 is r, and 24 over 4 is 6. So in total, in this side of the equation, we have 6 times 5. That is to say, we found out that r equals to 6 times 5. 6 times 5 is 30, so in conclusion, we found out that r, the radius that we are looking for, the radius of the circle, equals to 30 units. Here we can write down that the radius of this circle r equals to 30 units. Okay, thank you very much.